a three-state time homogeneous Markov jump process is determined by the following matrix of transition rates. Okay, given the distribution at time 0 is 1 by 3, 1 by 3, 1 by 3. The question is determine the distribution at time 1. Okay, the question is determine the distribution at time 1. Let's do this one. This is the question. Yeah, this is a very important question when it comes to concept building. If you see this question, what it says, first of all, remember the generator matrix is given here. How can you know? The first and foremost is to see. Don't go by the words, because sometimes it appears as if this is a transition matrix, because the words you see, matrix of transition rates. Okay, rates means this is generator matrix. If you add everything, -3 to 1, that is 0, it's not 1. So this is generator matrix. Remember, this is generator matrix. Generator matrix is given. But to find the distribution at time 1, you need transition matrix. So from generator matrix, you have to find transition matrix. Once you know transition matrix, then it becomes very easy. We've done this one. Okay. So what we do is normally we write this way, and we multiply transition matrix, whatever the probabilities, we write this way, P11, these are mu's, P13, then P21, P22, P23, time 1, we're talking about time 1, okay, time 0, time 1. However, although nothing is given here, this is a continuous time stochastic process, because generator matrix is given. This is the example from a continuous time stochastic process, but they talked about 0 and 1. That means though it's a continuous time stochastic process, we want to see only after each month. Suppose you are talking about stock price, okay, and stock price is moving this way. We want to know only after each month. We are interested in these points. We are not interested in between. So you find the distribution after 1 month. This is the question. If you want to know the distribution after 1 month, you have to know the transition probabilities. Okay. If you know the transition probabilities, then you can multiply the initial distribution. We are talking about 3 states. The probability that we are here, 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 and all that. And then what will happen after 1 time period? It's quite easy. However, generator matrix is given. That means what is given? For a very small time interval, the movements, the transition rates are given. Okay, whatever way it will go. Not this one time period. The 1 time period you are finding. That means you are finding transition matrix from generator matrix. So how can you find transition matrix from generator matrix? That is only through Kolmogorov's equations. There are 4 equations. We are discussing only one. Kolmogorov's forward differential equation. We have Kolmogorov's backward differential equation. We have Kolmogorov's forward integral equation also. Then backward integral equation. 4 are there. We are only discussing one till now. So you have to form equations to find P11 from mu11. You have to form a differential equation, forward differential equation, okay, and you have to solve it. Then you will get P11 T. P11 T we get normally. Then you take T1, and that will be this one, P11, okay. Even directly you will get the answer. If you want P11T, you will get the answer here only. Directly, this matrix you will get. Okay. So you have to find all this P11T. Then if you put T1, you will get the probabilities. Okay. So what you are doing is you are finding transition matrix from generator matrix. That means you have to find all. How many are there? 9. P11T, P12T, P13T, all P22T. So how many equations you have to form, and how many it looks very small, right? P21T, P31T, all these things you are supposed to find. But there are links, because if you know 2, the third one will be 1 minus these 2. So you need not find the third one. Okay, you need not find this one. You need not find this one. Like degree of freedom, the sum is 1, so we don't need 3. So you need 2 to 6. So 6 equations you need to form. However, even we don't need to find 6, because there are direct formulas for these diagonal elements. For the waiting time, okay, P11 means holding time in 1, P22 means holding time in 2, that way. So certain things we don't need to find, but 3 to 4 equations you need to form. Now let's go through the solution. Now if you go through the solution here, you might ask how to get these rates. If you are doing this kind of a modeling, to get these 3 rates, you have to do like the last chapter, that we have done for 2 states. In this chapter we have for 3 states. Remember the time spent under observation, that way we estimated mu there. Here we have to estimate mu 11, 12, 13. Okay, that you can go through. The derivation is not required, it's easy. It's like a 2-state model. For multi-state model also we have the derivation. I will show you once. See, this is the derivation. This is the derivation, okay. 1 by 3, 1 by 1 by 3, you have to multiply this matrix, okay. Now let's see how many equations are formed here. P3 to 1, if you draw the diagram, there is no 0 even given in the generator matrix. 3 to 0, okay, because there is no way. If you draw the diagram, you will be able to know. Even from the generator matrix also, you know that these are 0. So P's are 0. P33 is always 1. 3 to 3, because that is a dead state. Okay. Probability is 1. So these 3 we know. Also 2 1, if you check, there is no way you can go from 2 to 1. From the generator matrix you can observe that is 0. And P22 will use holding time, because this and this bar they are equal. So you can apply and you can find this one directly. You can form Kolmogorov equation solved in this case also. Okay. However, we have direct formula way to do. So 2 2 2 1 0, 2 2 you find. So 2 3 also 1 minus that. Okay. The total probability should be 1 here. We are talking about probabilities. Similarly 1 1 directly holding time probability you can apply and you can find here. Now here, if you remember, see, this is the integral equation. This we didn't study till now. What you can do is you have to form a forward differential equation and solve it, find it. This is a task to you. When I gave you that time, I had no way I could communicate that one to you, but yeah, this one now you can form a differential equation and you have to solve it. It will be big, maybe 10 lines, 8 lines. But if you use an integral equation, it becomes easy. This one we'll do next Sunday, okay? Then these are the probabilities. You multiply with this one, you will get probabilities after one time period. This one, okay? This way we have to do. Yeah, I have written also. Note that integral equations are not covered, so please do the above using forward differential equation. This is the question.